I've seen that most of the people that watch my videos aren't actually subscribed. So if you end up enjoying this video, please hit that subscribe button. It means a lot to me. It's completely free. You can always unsubscribe later. Touchscreens have become so commonplace we barely notice them anymore. Yet pretty much every single mobile phone in the pocket of every single person around you has one. And it's worth remembering that not so long ago, touchscreen technology was beyond even the wildest dreams of science fiction. You only have to watch the original series of Star Trek to see what's quite conundrum for us today wasn't even imaginable hardly a generation ago. And as if touchscreens weren't incredible enough, the resolution and vibrancy of colors that modern screens are able to reproduce is genuine scientific marvel. So today, we're going to examine what actually makes both these incredible technical feats possible and ask the question, how do phone screens work? The job of a modern touchscreen is to enable delicate, precise manipulation of objects represented on a virtual interface in the past. In the past, for example, on your dad's PC, that job was done using a mouse pointer that you drag around and click. But when personal computing migrated from dad's hulking home office beast to your much smaller cell phone screen, that sort of interface quickly became clunky and awkward. To work and to be useful, the modern phone touchscreen has to be able to pinpoint with some accuracy where exactly on the display your finger is touching. So how does it do this? Part of the answer lies in the curious electrical properties that lie within each and every one of us. Human bodies have what physicists like to call capacitance. That means our hands and bodies are able to conduct electrical current and even store electrical charge. You can see this for yourself whenever you touch one of those plasma ball ornaments in a gadget shop. At the mall, all these strange little bolts of lightning are leaping out to zap your fingertips. Because your body is a conductor, now underneath the toughened glass of your phone screen is a tight grid of essentially tiny wires, each thinner than a human hair. These hairs are made from conductive metal, usually indium tin oxide, which usefully is also transparent. Some of these tiny wires go horizontally from side to side, while others run up and down your screen vertically from top to bottom. Each wire is shot through with the electrical charge, and when your finger touches or in fact goes anywhere near this grid, its charge is distributed. Just like on the plasma ball, this is where the really clever stuff happens deep inside the brain of your phone. The disturbance and current caused by your finger is identified and tracked down to the precise location you touched. How? Because your phone knows precisely which horizontal and vertical wires were disturbed and by how much. It's a bit like using a map, reading the X and Y axes to find a particular city or country, but in reverse. So how about the picture itself? Until a couple of years ago, the industry standard for phone displays was LCD, or liquid crystal display. This clever technology uses a backlight the size of the whole screen. The light from this is filtered through twin polarizing layers, which filter out some or all of the light waves as they pass through. Between these polarizing layers is a thin layer of liquid crystal, organized into tiny cells commonly known as pixels. Each pixel is assigned one of three colors, red, green or blue, by the manufacturer. An electric signal tells each LCD pixel on an individual basis whether or not it should permit the glow of the backlight to pass through it. The combination of millions of these tiny red, green and blue pixels switching on or off creates the picture you're looking at right now. More up-to-date models instead use OLED, or organic light emitting diodes. These are a bit more complicated, but suffice it to say they don't need a backlight, as each pixel generates its own light source using organic chemistry from simple carbon compounds, which means that for you that this is the blacks you see on an OLED screen are blacker because there's no ambiguous black light to filter out, and your phone runs a little more efficiently, which is great for battery life. So in very simple terms, your phone touchscreen reads and interprets disturbances on a smart electric grid to figure out exactly where your finger itself, a conductor, is jabbing, and picture itself is not just a load of tiny chemical cells flashing on or off in three different colors to make pretty pictures. Other types of screen technology exist, but they're not very common in modern photos. Maybe in another video I'll touch upon those. So drop me in the comment section. This is it for this video. If you liked it, please hit that like button, and if you're new here, please consider subscribing. This is Eradication signing off, and I'll catch you in the next video.